Hi friends, once again Dahisar is here from the channel Kartik Tuitions. In my previous video, we have studied about tangent theorem. In this video, also we are going to learn one theorem which is related to your tangent. So let's start with the video. Today, we are going to talk about tangent segment theorem. Now, the statement goes as, tangent segments drawn from an external point to a circle are congruent. Let's understand this. I have a circle with a center O. So basically, we take a circle with a center O. Now, next part is external point. So I take a point P which is lying in exterior of a circle. When I say exterior, so that means point P becomes my external point. Now from point P, I draw a line passing through P and touching the circle at one point. Let's say it touches the circle at point A. Same way, I draw a line which is again passing through P and touching the circle at another point, let's say at point B. So here my A and B are point of contact. In other words, line AP and line PB becomes my tangent to the circle, and PA and PB becomes my tangent segments. And this theorem states that tangent segments, that means PA and PB, which are drawn from an external point P, are congruent. So in other words, segment PA is congruent to segment PB. This is the statement. Now let's have a look at the proof of it. First, it is given to us that we have a circle with a center O. Then we have an external point P which is lying outside the circle. So point P is an exterior of a circle. Then we draw a tangent from point P to the circle. So PA and PB are nothing else but our tangent segments. As a result, we get segment PA congruent to segment PB. Now see, whenever we have to prove two things congruent, we need the help of triangles. To get triangles, there is a small construction. We'll join OA, OB and also OB. Now because of this, we get two triangles. Which two triangles we get? We try triangle OAP and triangle OBP. Now if you observe, OA is a radius, AP is a tangent segment. So angle OAP has to be 90 degree. Same way, angle OBP will also become 90 degree. And the reason is tangent theorem. Now in two right angle triangles, always first check, is the hypotenuse congruent? In this case, yes, hypotenuse OP is congruent to hypotenuse OP, and the reason is common side. Then check, is one more pair of side congruent? Yes, here we get segment OA congruent to segment OB, radii of the same circle. So now both the triangles are congruent by hypotenuse side test. Once the triangles are congruent, we know the remaining elements are also congruent. Now when I say remaining elements, I just need the third side, that is side PA and PB. Now since the triangles are congruent, I can say segment PA is congruent to segment PB, and the reason will be CSE. From board examination point of view, this theorem is very, very important. If you are thorough with this theorem, you can easily score 3 marks in your board exams. So do prepare this theorem very, very well. Now let's have a look at one sum which is related on the same concept. Point O is the center of a circle. From point R, segment RM and RN are the tangent segments touching the circle at point M and N. If OR is equals to 10 centimeter and radius of the circle is 5 centimeter, then what is the length of each tangent segment? Now see, when they say length of each tangent segment, they are talking about RM and RN. Now let's talk about triangle OMR. Sir, once we get the value of Rm, we can easily get the value of Rn also, because R is an external point and Rm and Rn are tangent segments, so their length will be equal. So our first motive is to get the length of Rm. Now OM is a radius, Rm is a tangent segment, so angle OMR has to be equals to 90 degree. Now whenever we get a right angle triangle, we always first think about Pythagoras theorem. So here we get OR square is equals to OM square plus MR square, and the reason is Pythagoras theorem. Let's substitute the values. Here we get 10 square is equals to 5 square plus RM square. Now what is 10 square? 100. 5 square, 25. Now when I shift 25 on left hand side, it will give us 100 minus 25. 100 minus 25 gives us 75. So Rn square, we got it as 75. But we need the value of Rn. So we need to take the square root of 75. So in other words, Rm is root 75. Now 75 is not a perfect square. So first, let's check. Do we get any perfect square in the factors of 75? Yes. It is 25 threes are, and 25 is the perfect square of 5. So this, on simplification, it becomes 5 root 3 centimeter. Now, as Rm and Rn are tangent segments, so they have to be equal in length, tangent segment theorem. Therefore, Rn also becomes 5 root 3 centimeter. I hope you understood till here. Now, let's move to the second part of the question. What is the measure of angle MRO? Now, in triangle OMR, if you just observe, angle OMR is 90 degree. तो एक एंगल तो अपने को पता है. Now let's see OM and OR. OM is 5 centimeter, OR is 10 centimeter. So in other words, I can say OM is half the length of OR. Do you all agree? Now, if you try to recollect, such relation we have studied in 30, 60, 90 triangle theorem. Any side opposite to 30 degree is always half of the hypotenuse. Now, in this triangle, first of all, it is a right angle triangle. Then we got one side of a triangle as half the length of a hypotenuse. So, in other words, I can say OM is opposite to angle 30 degree. Now, when I say opposite to angle 30 degree, I will get angle MRO as 30 degree. And the reason is converse of 30, 60, 90 theorem. Once we get this, our second question is to find major angle MRN. Now, MRN is made up of two angles, angle MRO and angle NRO. So let's say first we have to find NRO. Now, similarly, I can get the value of angle NRO as 30 degree. Now, angle MRN is made up of two angles. That is angle MRO plus angle NRO, angle addition property. Now, both the angles are of measure 30 degrees. So, 30 plus 30 will give us 60 degree. In other words, measure angle MRN becomes 60 degree. I hope you have understood this sum also. Now, I have given you one sum in a brain gym, which is almost on the same line of the concept what we have studied in this video as well as my previous video. So just go through both the video once and then try the next sum which is given in your brain gym. O is the center of a circle. Segment AB and AC are the tangent segments. Radius of the circle is R and length AB is R. Prove that quadrilateral ABOC is a square. I'll just give you the hint for this sum. Now see, you have to prove this quadrilateral as a square. Now what are the properties of a square? The sides has to be equal, all the sides, and each angle has to be 90 degrees. Now, if you observe, point A is an external point. So, in other words, length AB has to be equals to length AC. Now, if you join OB and OC, they both will also be equal, radii of the same circle. And since B and C are point of contact, angle OCA and angle OBA will also become 90. If you just understand these 3 points which we have discussed right now, I'm sure you'll be able to solve the sum. Also, I'll be mentioning the solution of this sum in my description. So first try to do it on your own. If you are stuck up or you're not able to do it, then you can look at the solution. I hope you have understood the concept. Please like, share and subscribe my channel for the regular updates. Thank you.